Hi, here's our breadboard again. This is our uh, this is our chip, and this is the USB connector. The connector also supplies power and ground to the board. If you look at these lines right here, there's a black wire and a red wire connected to the rows of pins along the board. What they do is they make the ones that are labeled as plus 3.3 volts, and the minus one as ground, 0. The same is done on the other side, so you can connect to either side. You have to remember that the red line is next to the pins that are plus 3.3. Ground is connected to the pins that are blue, with the blue line next to them. Now, this particular chip, I keep pointing the wrong way, this computer chip is not connected to anything yet. It's connected to this guy, but it needs power and ground connections. So we're going to pull up the pinout diagram to do those connections, and then I'll show you what this looks like when it's done. Okay, now the first thing we have to do is wire our computer chip to ground and power. If you look at the pinout diagram on the front cover of the manual, pin 8 here is VSS, P19 is VSS. Both of those have to be connected to ground. That's the minus line of holes on the sides of the board. Here's VDD. That one gets connected to the plus, or the 3.3 volts, the line on the breadboard. Okay, here I am back with this board wired up. Connector and the pins. I'll never get used to doing this properly. Okay, look at the pins. Black wires are usually used for ground, red for power. So I've got these the chip wired up. You really want to make sure you've got it wired properly. If you see smoke coming out of your chip, that's a bad sign. Remove the power if you see smoke. They won't work if the smoke escapes. Okay, after that, if I think we've got this set up right, the next thing we do is we take the PIC kit 3 connector. The other end of the PIC kit is plugged into the USB port already. And to connect this properly, I need to just mate the two connectors like that. You probably hear a bum 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 bum. That means the laptop PC are figuring out this connection. It's all wired correctly, and now we can go to the MP Lab and see what we have to do. So that's it. When you open MP Lab, one of the first things it does is it checks connections. Right here you can see it's already detected the PIC kit 3. The first time you do it, it might want to update the software. Let it do that. Okay, let's go back to this program I have here. This program, move it down so we can see it. Come back here. Go up here. Right. This program, all it does is it uses the standard files to print out. Now, if I'm using the debugger, right, the MPLAB sim, and with the UART, and I run the program, having compiled it already, it's already pre-compiled in my case, it'll print out these numbers. What we want to do is we want it to program the chip. Select the programmer, PIC kit 3. Message says you can't have both. Okay. Say okay. Okay. It's making sure that we're all connected. If you get error messages, it might be because you wired your chip up incorrectly. There's a new bar here. This first one button here is the one that programs your program onto the computer chip. So we click away. Programming, programming, programming. Takes a little while to send the program to the chip. Hey, it worked. Now, if you look at your putty screen and, oops, sorry, didn't want to get rid of that, and you program it again, go call up the putty screen. If things are working well, that message should print out. Oh, sorry. Says inactive. Restart the session, the COM3. Now I'm going to program it again, go back to that window. You can see that at least partly it was able to print to the screen. I'm going to move something to the side. Okay, so you can see it's trying to print out. That's what we want to be able to do. We're going to make this a more efficient process a little later.